right, welcome back. It's 3:30-ish, so we'll still get started. We've got 3 speakers this last session. The first is here with me. His name is Mikko Nieminen. He's at the Berlin Institute of Health, and they have made a thing called SODAR, the iRODS powered system for omics data access and retrieval.
Thank you. Good afternoon, and thanks for having me. I'll start with a quick bit about myself and my employer. So I'm a senior software engineer at Berlin Institute of Health, which is a biomedical research institute. And it's also a joint venture between the Max Delbruck Center for Molecular Medicine and also the Charité University Hospital. So is everyone sufficiently confused now by all these names I dropped? No one knows what I'm talking about anymore? Good. We can continue then. I'll be presenting kind of a case study of how we have been using iRODS in this system for omics data management in our unit. I'll go through some background and goals first, what we set out to do and why. I'll walk you through the design of the system itself and how for example, iRODS comes into play. I'll have a bit of a rare disease genomics use case demonstration. It's a live demo. It's 99% offline here on my laptop, but probably will go horribly wrong, so at least you'll be entertained by me trying to make it work. After that, a bit of status and where we are at in the real world, like outside of my laptop, a bit about ongoing work, what we are doing now, and a bit of conclusions in the end. Everyone with me so far? Good. Everyone coffeeed up and alert? That's great. This will be pretty high level, and I'll be going through a bunch of stuff, so feel free to ask questions afterwards or catch me or my colleague Manuel like anywhere in the event. We'll still be here all day today and tomorrow. So background and goals. Oh, that color doesn't look good. I hope this isn't the case with, no, it's only this slide. Well, that's interesting. It didn't do it before I said, oh, well. So anyway, I'm from the core unit bioinformatics. And basically, long story short, we kind of are a service-oriented bioinformatics team. We provide everything from data processing to consulting and methods and software for other BIH projects, and we work together with like clinical researchers on a whole lot of different subjects. And as you might guess, we work with a lot of data. I'm sure that comes as a surprise for you in an event like this. So what kind of data do we work with? We basically are dealing with high throughput data coming from sequencing, also metabolomics, proteomics, basically large data sizes, a lot of measurements. At this rate, the data is also pretty heavily processed already. It's already reduced in size, so it's not as much of a question of we have a lot of like trash data. Actually, we have still a lot of data which is actually useful. We want to be able to store it, access it, find it maybe even like years later, and somehow manage this process of all the data we end up in these projects. How is this done traditionally? I'm sure you heard this story before. People do Excel sheets and then store data in portable hard drives and pass them around, and they get lost. And yeah, as probably all of you, one would want to get away from this situation. What are kind of our requirements for making this more manageable and sustainable? So yeah, we need like a unified storage for this raw data. Like I said, large files, they kind of pile up quite a bit. We need to maintain some kind of context between the study design or the study metadata and the actual raw files, which makes us able to actually locate the correct data we need. Data protection and access control is pretty crucial because, of course, we deal with data coming from, for example, patients, and especially in Germany, it's pretty strict legal issues what we can do with this. And of course, you have heard the FAIR principles in many presentations before, so also we aim for that. And one important facet is multi-institute collaboration. As I briefly said in the beginning, our institute is formed by 2 institutes, so basically both need to have access to everything, and preferably without having to come up with some new credentials for our systems, so that's kind of a very important need. To that end, we basically set up to develop a system which answers this particular use case. Now, this was before my time, before I joined the unit, but some work was done in looking into existing systems, and none was really found which would actually fit our specific use case. We weren't looking for something generic, but something which really would fit into the workflow, ease the work of researchers, make their data actually discoverable, help with the study modeling and so on. So basically, all the requirements I said before, that's what we intended to solve. And you see from here kind of where this system would sit. So basically we would offer both the researchers some interfaces to access their data, like upload their data, so on, access the study design, also APIs for programs and scripts. So we could integrate this also to like the analysis pipelines we have. Of course, this should talk to the cluster we are using. We need an archival system, and also third-party data should be linkable to the system so that you actually could find the context for all this data in one place. Easy enough fit, right? Like, yeah, that's simple enough. Why did we choose iRODS? There's some rationalization. Well, of course, we like the scalability and replication support. We really like the metadata functionality. Like I said in the beginning, like linking the metadata to the raw files is quite important to us. The rule engine is pretty great for like doing automated stuff for data validation and stuff, and just flexibility. We can pretty easily integrate and install this in our own infrastructure. We have actually like our own server farms, or basically what we are using, and also PAM support, which is great for the multi-organization requirement we have, and of course the nice community. Like, I think we attended first with my colleague 2 years ago in this meeting, and we were impressed by the nice sharing of knowledge here, and this was great. Why don't we just stick this data into a third-party cloud providers somewhere? Why am I talking about our own infrastructure? Well, first of all, the data protection issues are there. Like we can't just go uploading this to anywhere. And of course some cost issues. We are a research institute and the data keeps growing, and at some point it might not be feasible. Also, as mentioned, we like flexibility in iRODS, and if we do require to do some stuff in the cloud, well, the S3 support is there, so we can actually work with that. So iRODS was basically a pretty easy choice for us in the beginning, and as you probably might guess from me standing here, we are still using it and we are quite happy with it. Now let's talk about the design a bit. How does the average user see SODAR? Well, it's a surprise. It's a web interface. With also REST APIs if you want your scripts to interact with it. You can access it with existing credentials. So in our case, in our instance we deploy, it's like you can log in with your normal Charité account or your normal MDC account. You don't have to do anything. Same with the website, same with iRODS, same with everything. It's all your usual accounts, which is a small thing, but it's really great for the users. We organize data in projects, which are organized in categories, just to kind of sort them out. We assign project-specific roles to users, which are used to govern access, both in the web interfaces, the REST APIs, and iRODS files, and everywhere. This is a pretty simple system right now, because we kind of wanted to start it simple and then build on it if needed. In the future, we probably will make it a bit more fine-grained if needed, like different user groups for projects or something. But this has worked pretty well in our use case. We maintain project metadata, like strictly related to project and like applications in our own database outside of iRODS, but also some metadata which is useful from the iRODS context we mirror in there using the iRODS metadata facility. We generate audit trails from project activity, which also a pretty major requirement for us. And we kind of generate UUIDs for every project-related object and can access them through there with the APIs and such. So basically every application we have follows the same framework of access. How do we manage study design? Well, you already heard a bit about ISA standard in the previous presentation. I know that there are people in the audience who are familiar with it. Maybe some of us are not, and it's a pretty complex thing to go in this presentation, but basically it's just in this model data is organized into investigations which may contain one or more studies, and each study may contain one or more assays. It's actually a graph model which usually represented to user as tables and edited kind of like in a table way. We feature like our own made browser to actually view and interact with these sheets, link out to external data, link out to iRODS, automatically create iRODS links based on like what we know about the samples and so on. And I have to advertise our Altom is a parser, which has made in the Kubi team, not by me, but my colleagues, and it's great if you work with isomodel files, you should get it from GitHub right now. It's much better than the official parser. How about the files itself? Well, I mean, this comes as a surprise probably, but the data files, the actual raw data files are in iRODS. Again, we organize them in collections by project. Everything is done project-based. That's the context we have. The user access is managed by the SODAR system. This is not actually fancy, if I'm being honest. It's mostly we create a user group for each project, and then when access is given in the actual SODAR system to a user in a project, we give them access to the user group of that project. So that's pretty standard ACL stuff. It's not really like, it's not fancy or anything, but it's done its job, like it works. Again, iRODS can be accessed via PAM with the same credentials anywhere else. And we will link out this stuff in the web interface. I will show that to you in a moment if I have time. How we handle data uploads. Okay, we have this concept of landing zones. It might not be exactly the same landing zones we have heard in, for example, Chance's presentations, but basically the project repository is always like basically immutable or read-only, and we provide these landing zones where the user can do whatever they want, and then they submit that to validation and moving to the actual repository. And we have some validation rules. Again, right now it's still fairly simple, but just to make sure that, you know, integrity of the files, you're not trying to overwrite anything you're not supposed to, and things go in the right directory, and, you know, basic things like that. We're actually working on some nice extensions on that in the near future. How do we do this in iRODS? This might be an interesting thing, and there's kind of an interesting story how we came to do with this. So in our use case, basically, we expect the user to upload this set of data, like whatever, from some run, or let's say it's rarely just one file. It's usually for several samples, certain operations. And we want to make sure that when they do this, it will succeed, and we are not left with like half of the data in our repository, half in the landing zone, or maybe some broken files here and there. So we are pretty strict about this. We have this task flow engine, which basically wraps all the iRODS operations into a transaction, and if something goes wrong in that transaction, everything gets reverted and the user gets an unpleasant message about something being wrong in their data. At that point they can go back to their landing zone and fix it and try again. Why did we do it? We did this using the task flow component from OpenStack. It's basically just a Python REST service which talks to iRODS through the Python iRODS client. And I know the immediate question is, why didn't we like try using the policies or rules or stuff? And the honest answer to that is that when we started doing this, we definitely were not like iRODS experts. Probably we still are not. And the whole rule and policy engine thing was a bit daunting. And we were like, let's start with something we know. Like we know this stuff, and this is fairly simple. Actually, the most complex thing was writing all the kind of logic for reverting things and thinking of all the possible ways some iRODS operation could go wrong. And oh boy, there have been many cases I didn't expect, and there have been many bug fixes. But that's basically right now what we are using. Maybe we could replace with something iRODS internal, but we'll see. Also, this updates the status in the actual SODAR system so that the user knows all the time what is going on, like what phase of the process we are in, are there any errors, and so on. It does make some use of iRODS rules, but again, I have to be honest, it's very basic, so nothing to write home about or go into detail in this presentation. How does the user access iRODS data? DAVRODS is like the most common way. Obviously, some people, expert users, mount a DAV, but most just access by the website. The random access to large files, which was introduced in DAVRODS, when it was like 2 years ago, something like that. That has been very useful for this because we have these huge files and we need random access to them instead of like downloading huge 10 gigabyte files to the user. Our users use the IGV from Broad Institute quite a lot, and we have integrated our system with it so that we generate the session files automatically to point to the actual samples and relevant files to them. And of course, iCommands are there for the expert users, mostly for data ingestion and working in the landing zones, but not so much for just accessing the data. Usually people prefer these kind of simplifications. I'll go through this really fast because I'm running out of time. Like I said, we started off with writing kind of a very specialized, very domain-specific tool, but as sometimes happens, we at some point noticed that, there are actually quite a bit of reusable components in this, and we realized that within Kubi, our team, we would have use for those facilities in our other projects. So long story short, we now have the core features of our system available in GitHub. Basically, they have the project management framework, the app deployment framework built on Django, the Python framework. We kind of do some things with it which are not usually done, and it can be used to both build your own projects which have a bit of different configuration, different apps, and also share these project access rules between sites. So let's say if you have, your organization has these projects, but you have kind of separate concerns or separate data or separate functionalities, you can actually use this to only have to manage the project access in one place. It came as a side project, but it's been kind of nice, and you can check it out in GitHub as well. Something about technology, like I won't go in detail. If someone wants to talk about more about this, then come and catch me. And a very confusing architecture. We don't have to go through that in detail again, but basically that describes what I was just telling you, and I don't really understand it either anymore. All right. Yeah. I think I have 10 minutes, so let's quickly go through this rare disease genomics use case in a live demo. Like I said, it's a live demo. It's offline. It's on my laptop. Probably still will somehow break, but we will have to live with that. Don't worry if you're not into genomics. I won't go into this in huge detail because neither am I. I'm not a bioinformatician unlike most people in my team. I'm such a software guy, so I'm here to show some UI for you. I'll begin by logging into our web account. Normally I would log in with my LDAP account, but from here it's not really feasible, so I just have like a local account, which I apparently don't remember the password for. That's good. That's always good. No, I actually will not remember it. This is interesting. Oh, I didn't use my normal username. That's the problem. I told you something would go wrong. So okay, I'll skip the boring features. I can give a more concise demo here later. Just come and grab me. I still have my laptop with me. But basically, yeah, I see some projects. There are not many because this is just a local instance. Let's go to our demo project. We get to our details view, which basically shows you. Sorry? Oh, font. Thanks for noticing that. I think I can probably. Better? More? My resolution is too big. Is it okay now or still? Anyway, so we get this kind of overview. Basically just shows the latest data from each app. What really interests us is the sample sheet, and here we get to the actual use case. So yeah, this is a rare disease example from public data. So this is pretty simple. We only have like 4 sources or donors or patients here. We have a family of like 2 parents and 2 children, and one of the children is affected with something, of course I don't know anything about, but that's good because we can actually link out this ontology reference of telling what the condition is. So simple things like this, but we don't have, yeah, that's really small, but you just have to know it's there. You don't have to read that, don't worry. And we have some linkage to external IDs too. If there's like external IDs from some other sources than like our UUIDs, we will have them there. And if you are familiar with the ISATAB format or the ISA standard in general, you probably kind of see something familiar in this. So we have the study, which is basically the sources, and here we have the samples derived from the processes, and then we could have 1 or more assays. Now we have just 1, which describes basically the whole process from extracting things from the sample and traveling towards write coming to the library. And so this one, of course, is like a genome sequencing assay. We see that here are some links to files, but they're grayed out. But that's cool because we don't have anything there. We will put something there in a moment. Yeah, iRODS shows 0 files there. That's probably too small to see, but that's what it says. Let's go to our landing zones. I have prepared a landing zone. That would have been boring, so I just did an IR sync to a local iRODS instance, which froze my laptop for a moment. That was very entertaining. So we can see here that we have like files for that. Basically, that case, it's 28 gigabytes for these four samples. So you kind of can, if I tell you that we have dozens of projects in here which might have like, I don't know, what's the biggest, like 600 samples or something like that, and you might imagine that the size of data does grow quite a bit. And I have already validated this. I did my homework, so we can actually move this to the repository. So we click this. Are you sure? I'm sure I want to do this. And we can see about the status here, what will happen. Let's hope this actually works. Oh, it validated okay, so we are moving the data. There shouldn't be anything going wrong with that, but we'll see. It's not actually super slow, but it's just updated, not super fast. Okay, so we moved the data. Actually, now we need to wait for a moment because there's a background process running, which is on this laptop. It's a bit slow, but now the data should be there. Let's go back and see. Now we actually have 5 minutes. So still time for like one question. Okay, now we actually have some links enabled here. So we can go here for the assay. In this use case or in these kinds of projects, German project, we expect data to be organized under the libraries. So for basically each library, we have here links. We can get like a quick iRODS file listing. This is just like a flat list if you want to make sure that something is there. Like, I don't know, let's see something. And these links lead directly into iRODS, so you can just go and open it here. We have iRODS now, and so that's kind of just like a quick access thing. We also have other facilities here. We can copy the I commands, like the iRODS path for I commands from here, and we can go to actually the iRODS. It has a bit of our own. There's a login thing, but you didn't see it because I already logged in before. So we can actually go and browse this stuff. We can mount this iRODS or whatever. Like I said, this is the primary access point for people just wanting to browse the files. Now, what is the more important or interesting part is the IGV integration. So here, in this case, we are considering the pedigree, so the family. So we can actually see that we have the read alignment files, the BAM files here for each of these sources, and for the family, we have a variant call file. And these are used to build the IGV session file, which we could download from here. But then again, why download it here? Because we can just call IGV. I need to log in. Hopefully I remember this time. And we should be getting, yeah, so we generate automatically kind of the session file to have the data for the whole pedigree. Then we can zoom in. This is like not my expertise anymore, so like I know there are many people in the audience who actually know this stuff better than me. But the point is that we can do stuff like this. So we generate a file on the web front end, which is XML session file. That file points to the iRODS files through iRODS, and with one click, the user can open all of these at once, and they don't have to know which files belong to this source, and they can go searching for it. This was actually easy to implement, but I've been told that it's like a really killer feature for the actual researchers. So that's kind of cool. And there would be a lot more, but yeah, come and see me for the longer demo if you want at some point. I think I still have some slides to go through. Status. So yeah, this does exist outside of my laptop. We have developed it. We have deployed it at Kubi. It's in pretty heavy use. I don't know, something like 60 projects when I last checked are using this right now. We also have a second instance at the Bonn University, and we are in talks with other people who are interested in collaborating. Very much in development, still like the issue list never ends. We will make this public when we kind of reach the 1.0 version at some point in the future. The core parts are already public, so go and play with them if you want. We have 4 projects using the core package right now, and some of them are already being made public. Next major step is doing like an actual editor for the ISA tabs, which works for our use cases because the The official editors are kind of, well, maybe not so in such a good state anymore. We want to do more advanced validation, as I mentioned. We want to do a more comprehensive REST API. Not quite everything is in there, and so on and so on. This is a very much ongoing project. What can I say? This has already been proven to be a valuable aid in the original use case. Our researchers, it's in daily use. I get very angry emails if it's down for some update for a while, and I know that this is important to them. We have gotten interest from outside organizations, one of whom which we already have a deployment going, and this is going to evolve further. And like I said, we have been happy with iRODS. To be honest, we still use it in a very simple way. Our deployment of it is very simple. We basically have one file server for an instance. We don't do much in ways of replication, but this is on our to-do list, and every time we come here we are kind of amazed to see what actually people do under the hood, and we probably will be working quite a lot more with it. And especially with the rules, and also we will evolve that as well. But that's, some acknowledgements. Of course, the entire iRODS community deserves thanks, but especially Chris for his work with DevRODS. I think Chris is not here today. I think he'll only be here on Friday, if I understood correctly. That was very helpful. A lot of BIH researchers who use this have been super helpful with bug reports and feature requests. Dieter Boyle and Manuel Holkweber, who's sitting right there, deserve thanks for a lot of requirements and design help and support and feedback. Matthias Kuring for the Altom parser, without which there probably wouldn't be ISO support right now, and also Franziska Schumann for code contributions. Phew.
Hey.
I think I went over by a minute, sorry, but thanks. That's all I had. So. Except, feel free to contact me, and like I said, come to talk to me or Manuel if you're interested in hearing more.
Will you be here Friday as well?
Sadly not, but tomorrow, yes.
Okay. Any questions? That was fast. All right. Thank you again.
Yeah, I think everyone wants to move on. Thank you.